Yeah, hi everyone. Thanks for the introduction. Like Bojan said, I'm Simon Thommes and I'm going to talk about procedural texturing in Blender, which is not that famous of a topic. So let me quickly introduce myself. That's me. I'm a student of physics at the moment in Aachen, Germany, but I'm also a self-taught 3D artist, or what you might call a generalist in my spare time. I started using Blender 9 years ago and didn't leave go with it because I wasn't really squeezed into any specific software due to the industry, because I'm basically doing it as a hobby up to this point. But I'm eyeing on Houdini, that looks really good. A few words about the presentation. When I got asked to do this talk, I was really excited to tell you everything about procedural shading in Blender that I know, to talk about all the specific tips and tricks there are, but that's obviously not that realistic in the time frame. So I settled on a few goals that I want to achieve with this talk, which is showcase some of my personal work of various different procedural shaders that I've done completely in Blender, and with that display the capabilities that Blender has today for procedural shading, but also what you can learn from that for any other software, basically, because the concepts that I'm using, that I'm basing my whole work on procedural shading on, are very fundamental and can be applied anywhere, basically. So with that, I'm hoping to maybe inspire a little more of a mathematical workflow in your everyday shading life in any software, basically. So yeah, like I said, I'm going to start with a short showcase of different procedural textures. Keep in mind that these are mine. There's a few other people that do basically similar things, and that's just a selection that I made for different categories in procedural shading. So first up, I have a category I call basic patterns, which is just very regular patterns that aren't that hard to accomplish. Like in this example, the knitwear. And yeah, as you can see, I have a logo mapped onto that, which behaves accordingly to the pattern of the knitwear. And yeah, the detail comes through micro displacement, which is just Blender's method to make some high tessellation for displacement. So that's obviously not real time, but I'm going to show you the same project basically in real time. It's a bit hard with one hand. So, as you might know, there's been a lot of development with Blender in recent times. They are pushing a huge update for July, which is already in beta, and you can use it as much as you want, which has an amazing real-time renderer that goes hand in hand with the ray tracer. So you can create the same shaders for real-time, like you see it here, and ray tracing. And I can just move it around, and here you can see the node setup that I'm using. And I can just change anything and see the results in real time. As you can see here, the division, or some other settings. I don't know how well you can see it. Just some general settings. And this node here is basically a custom node that I made from scratch, that you can apply any other sort of pattern to. It looks like this. It's a bit more complicated. Doesn't fit on the screen. And that's called a node group in Blender, and you can just plug it into any other texture and set up your own parameters. So yeah, that's about basic patterns. But you can also make some more custom advanced patterns, like the scales for the snakes I did here. And like the node group for the knitwear, I also have a base texture for the scales, which is exactly the same node group for each scale, even though they have a different shape. I have the same thing in real time as well here. As you can see, it runs very smoothly, the different shapes here. And if I go to the node group here, I can just adjust the shape of these scales with an RGB curve in real time. So yeah, that's about the custom. Sorry. that's about it for the custom patterns for this section here. And you can also do more advanced stuff like custom placement of textures. That's a bit more complicated because I'm using very basic tools, like I said, but it's doable. What I mean by that is the leaves that you can see here in the mud are themselves not procedurally created. They are photo scanned. That's the first thing you see here. That's not procedural, but the placement and the rotation and everything is completely procedural, and the rest of the material, the mud, is all procedural in Blender. This is just one plane with this placement and a procedural shader. I'm not going to show that in real time right now because it's a little bit heavy on the machine. So next category would be context-sensitive shading. What I mean by that is that you can take the geometry of your file into account. For example, here you can slightly see a little bit of dust building up on top of the model, or you could do anything with that, basically cavities for your model. I also have another example I want to show you, which is animation-sensitive shading. Here we go. So I made a lighter with a flame that is procedural, and I made a short animation. And the behavior of the lighter flame, according to the movement, is completely procedural as well. It's done with drivers in Blender, which is just a really tiny snippet of code that you can apply to your shaders. And to stay with the theme of fire, I also have a category that I call procedural volumetrics, and this fire is also completely procedural. There's no simulation going into that, and it's volumetric, so you can turn around and look at it from every direction. I have it here as well. In real time, it doesn't look that good when you animate it. It's a little blurry, but as you can see, it's animated. And again, you can change the settings as much as you want here. And then as a last category, I have something that can only be categorized as shaders that shouldn't be procedural. But why not? I mean, we can do it, and you can also do it in Blender. There's amazing examples for Substance Designer, but yeah, you can do it in Blender as well. Okay, so how does it all work? Like I said, I'm using very fundamental methods, and I'm using a very tiny amount of tools, which is mostly mathematical. So the first thing that's important to understand is that Blender is working with vectors, not with pixels for texture generation. So you basically have your procedural shading directly in your 3D space with the vectors of the coordinates that you put in. So the basic root of all your textures in Blender are the coordinates. May that be the two-dimensional UV coordinates that you map your object onto, or the three-dimensional generated local coordinates, whatever that is. And those you can split up into X, Y, and Z coordinates according to red, green, and blue. And then there's a tricky part. I have an example here of a fairly simple fishbone pattern. And if you think about the texture as according to their coordinates, it's basically just a mathematical function. You have an input of the coordinates, in this case here just X and Y, and you get an output of a color vector in RGB. And as you can see on top there's the formula of the function, and down is the implementation in Blender. I know it doesn't seem that easy to follow, but the workflow, how you approach it, is not that you write it down directly, so it's a bit simpler. I have a few examples how you would approach something like this directly, specifically, with a little example with visualization. I set up a file where you can I quickly have to explain this on top, right, left. you can see the square with the texture that I'm working on, which is made with the nodes on the left. And next to that, you can see the profile, basically, and the value profile. And here you can see the displacement, basically, that it would be. Right now, I just have set up a Musgrave texture, so you can see what it does. But I'm going to delete that. And this is not that easy with one hand, but I'll try. Now I'll separate the input coordinate that I get into the components. When I plug in the x-coordinate, you can see that it behaves like you would expect. You have, in the negative area, you have black, and then it goes from black to white, from 0 to 1. And you have the linear function, basically, of the x-coordinate here. And yeah, here it's just in 3D. Now what I can do with that is basically any sort of mathematical operation. I just add in a math node, which just adds this mathematical operation. Set it to multiply, for example. And now I can scale this x. Now if I want to get repeating patterns, I can, for example, add another math node and set it to, where did it? Here. The fraction, which will just give you the fraction of the number after the decimal point, so it repeats every integer, basically. And as you can see, if I change the multiply value beforehand here or now, I can scale the size of the pattern. Now another thing that I can do to get some more control over the profile of this function is I can add, that's a little bit too much, an RGB curve. It's basically the same process that I showed for the snake scales. And if I change this curve now, it behaves accordingly to the curve, actually, exactly. Okay, but to create actual two-dimensional patterns, you'll have to use more than one coordinate. So you can combine, for example, now the y-coordinate. Another mathematical operation, I will set it to greater than to compare the modified x-coordinate to the y-coordinate. Now we have a very simple setup where we can control the exact shape, which is repeating on top there. So that's just a small window into the creation of the shaders that I did. I don't have enough time to go into every little detail that makes it up, but these are very basic operations at their core, but you can learn some tips and tricks to create with to use these as tools, basically. Okay, I have an other visualization. Because you're working with coordinates, you can't only change the outcome by going from left to right to add your operations, but you can also change the root, basically, of the coordinate that you put in. So here I have a simple node group that creates a hologram for a cylinder. I can rotate it around here. And now I can change the vector input that it gets fed into the node group. And now I can, for example, put in a color or a vector, which is basically the same in 3D as a 3D vector, and shift the whole thing. But I can't only shift it. Here I have a noise texture. This is what it looks like right now. And I don't have to feed the same value for every coordinate into the shifting. I can also put in like a texture like this. And the result is quite interesting. I got some distorted coordinates like this. So that's the other concept that you have. Not going from left to right, but changing the input coordinates that get fed into the outcome. Yeah, and that can give you quite interesting results. Okay, But after all, this is a conference about content generation for games. And I'm not really an expert on this field, but I'll try to add my information on that as well. The simplest answer, if you just use your UV coordinates to bake anything that you create in Blender, it's no problem at all. It works like a charm. So that always works onto your low poly mesh, basically. But there also is a problem. If you want seamless tiling, it's not that easy, because natively Blender has no support for seamless tiling in the base textures, and what you need to get a result of a seamlessly tiling texture is just using all seamlessly tiling base textures. So you have to work around it. There's two methods that you have to use there. Basically, if you're creating a pattern like the bricks that I'm showing here, which are also procedural in Blender, you have to create the pattern seamlessly tiling by design. But if you're using a base texture that's like a noise texture, it has to bring that on its own. But in Blender, that's not the case yet. There's probably some developments in the future, but right now not. So you'll have to work around that by, for example, making it seamless by shifting it and blending between in the different points of your texture. But that's a whole other topic to talk about. But yeah, it's possible. And for this example, I did it. As you can see on the right, it's the final render with micro displacement, and there's the different PBR textures. And I baked them in 8K and ported them to Unreal Engine. Now, like I said, I haven't done a lot with game development yet, but I try to get into that a bit. And you can see that it's tiling, and you can see no seams. So it works, but it's not that simple. Okay, I'm already coming to a conclusion. And what I wanted to say is that you can use Blender for this kind of stuff. If you should, that's another question, that's up to you. But the main point that I want to make with this presentation is that you can include mathematical workflows and basic tools into your workflow to make it more efficient or more flexible. Because what I found is that having a very limited amount of tools can be creatively empowering, in the sense that you will have to find ways to work around something. And if you understand the fundamentals of what it's all based on, then you have all possibilities open to you, actually, with a very limited amount of tools. Of course, that's not the quick and easy way. It takes time. So in Blender, you can, for example, use these node groups that I've shown. The stuff that I've done you can find on the internet on my website and download there. But there's lots of people that do this similar kind of stuff. But if you want to get that into Blender natively and want to push the development, the best place to go is to the development fund for Blender and throw a few bucks towards the developers. They are making great stuff there. Like I said, pushing a huge update in July right now. And yeah, if you want to follow up on the stuff that I do, there's where you can find me. It's basically just my name, but if you didn't know that by now, there it is 3 more times. So yeah, thanks a lot for your attention. I think there's more time for questions, so feel free to ask.